I'm Rachel Kelly and I'm the knowledge broker at Aqua. We're the Aquaculture Council of WA. I'm based in Broome in the Kimberley, but I'm actually currently in Nipaluna, Hobart. So firstly, I'd like to acknowledge the traditional owners of the land that I'm on in Lutruwita, Tasmania, who are the Muwinina people. And I pay my respect to elders past, present, and emerging, as well as to the many Aboriginal people that did not make elder status, and to the Aboriginal communities across Australia who continue to care for country today. So welcome folks to this webinar on local climate implications for WA aquaculture. This webinar is the first of a new series that's linked to the Aquaculture for the Future programme, which is funded by DPIRD and the Australian Government's Future Drought Fund. Aquaculture for the Future is a training programme for WA aquaculture businesses that supports the industry be better future ready. So if you'd like to know more about that or how to participate, please get in touch. But the focus of today's discussion is on the climate risk assessment for WA aquaculture, which was recently conducted by researchers from the University of Tasmania. And this qualitative assessment is a first for WA aquaculture. And we, who are Aqua, have just published the assessment report online today, and we'll share some more information on how you can access that shortly. So we have lots to cover. We'll get straight into introductions, followed by presentations, and then from our climate experts, and then lots of time to ask questions and get to know more as you want. So I'll just go and introduce some of the key folks who are joining us, and then I'll hand over to Justin, our CEO, for a more formal welcome. So firstly, I'd like to welcome Dr. Arani Chandrapavin, who is a DPIRD scientist and climate and marine heatwave specialist. Arani has over 20 years experience working on a range of biology and assessments, and her focus is on understanding climate change impacts and risk, and obviously particularly marine heat waves. We also have Professor Greta Petzel, Order of Australia, who is a Professor of Marine Ecology at the Institute for Marine and Antarctic Studies at the University of Tasmania, and she's also the Director of the Centre for Marine Socioecology. Greta is a lead author for the International Panel on Climate Change, the IPCC assessment reports, and she's also an Australian Research Council Future Fellow. And we have Dr. Hannah Fogarty as well in the background on that screen, who is a research fellow and exec support officer at the Centre for Marine Socioecology at UTAS, and Hannah has a PhD on climate change adaptation and preparedness in commercial fisheries and aquaculture. She's also worked in industry as a policy analyst for UN, so is bringing these two perspectives together today. And lastly, we have Justin Boulanger, who is Aqua's CEO. Justin has over 25 years of experience in research, policy and development, all related to aquaculture, fisheries and NRM. And I will hand over to you.
Yeah, thanks, Rachel. Look, I just wanted to say firstly, thanks all for attending. We have 27 people in the meeting at the moment, so it's a great endorsement of this new sort of approach that we're using to get information out to the sector and to our broader stakeholder group. So thanks to all of you for making your time available. We'd really like to get your feedback after today on how you found this works for you and what else we might want to do moving forward. So I think it's fantastic we're able to share with you both the really significant and unprecedented work that Greta and Hannah have done in terms of us understanding what the implications for climate change and is for the sector in WA. So I'm really pleased to be able to share that with you along with the release of the report, which should happen this week. And also for Arani to be present to give us a bit of a local perspective as well. When we ran our RD&E workshop at the start of the year, one of the things the industry identified is they want to know at a more local and sub-regional level, what the implications were for them. So this is the first step in that process. We still have a way to go. We want to do some more quantitative assessment for the industry so they can better understand precisely what those implications are going to be. But really, really pleased to have everyone here to present the work that's been done so far. So thank you very much to everyone who's given up their time. And because I'll probably forget this at the end, my thanks to Rachel and Danny for all the logistics and convening for everything today. Much appreciated. So Rachel, I'll just hand back to you and you can MC from here.
I think you can just hand straight to Arani, who's going to kick off our first presentation. Right. So we'll hand over to you. Thanks, Arani.
Thanks, Rachel. Thanks, Justin. Good afternoon, everybody. I do have quite a bit of slides. I'm going to jump straight into it. So just first of all, I just want to kind of mention the fact that climate projections information and climate data can be quite overwhelming and also confusing. And that's likely because it's presented in so many different formats and there's different modelling outputs. Usually you have some kind of a baseline or a reference period, and then most of that information is then projected out to a future state, a future climate state, whether that's a time period. So you pick a decade that you want that information to project out to. Some researchers present that information for different emission pathways. And more recently, with the National Climate Risk Assessment Framework that's been published, they took the approach of presenting this information for different warming levels. So whether it's 1.5, 2 degrees or 3 degrees warming. So on this slide, you could see all the different collective different projects, different reports, different website tools that's publicly available and accessible to try and understand this climate projection information for your particular region. So I've used a number of these sources, summarised them to try to understand what that means for Western Australia and specifically the ocean climate domain. But I'm going to keep a lot of that information very high level and not really drill down to the finer spatial scales where a lot of that information is less confident in terms of that projection. So overarching, a lot of our ocean climate conditions, seasonal information and annual trends are really influenced predominantly by some of the more major climate drivers. So a lot of us are familiar with the big one, the ENSO, which is the climate driver that operates in the Central Pacific region. So you've got the La Nina phase, which is the cool phase. So you can see that central region of, I don't know if you can see my mouse. So it's a central region of the Pacific. It's quite cool. So those are the blue shades. And that's largely driven by, you've got strong trade winds blowing from the east to west, bringing up cooler waters to the surface. And so you've got this buildup of warmer waters sitting on the western side of the Pacific that then filters down through Indonesia and influences the leeward current of our west coast. So that's La Nina, the cool phase. The warm phase is the El Nino, the opposite. So here you see, mostly warmer than average temperatures. That tends to relax the leeward current, and we tend to typically experience cooler temperatures of the west coast, or at least from the Gascoyne down south. So that's the big climate driver for the Pacific. Likewise, in the Indian Ocean, we have another climate driver known the Indian Ocean Dipole, and it also has that cool and warm phases. So we've got a negative phase where we've got warmer temperatures sitting to the eastern side. And then we've got a positive phase where we've got cooler temperatures sitting. And this is also to do with some of those wind and atmospheric conditions. In terms of those long-term climate projections around these big climate drivers, there's very limited information and research out there, just largely around the confidence in modelling that far out, particularly when we have such a rapidly warming climate. With the limited information that I've been able to kind of find, there tends to be a little bit more shift towards experiencing more El Nino-like phases of the ENSO in the future than La Nina, and more positive IOD events than negative. But I think there's more consensus that both these phases are likely to be a little bit more extreme and much stronger than what we have experienced in the past. And just to put that into context, currently right now, so this is the global sea surface temperature anomaly map of the globe, and you can see that we got a really strong negative IOD climate driver in play in the Indian Ocean. And in the Pacific, we've got the beginnings of a La Nina that's been kind of developing over the last couple of months. So these two climate drivers have been mentioned quite a lot in the media around what that means for the summer outlook and rainfall and temperature patterns. And also, I guess for us, it's what does that mean for the water temperatures that we're going to experience this summer, and the type of impacts that we can potentially have. So coming back to the Lewin Current, this is our major ocean current for the West Coast that really hits our coast south of the Ningaloo and travels down. In terms of future projections of the Lewin Current, again, very limited information out there, but there's two pieces of key research, one more recent that's about to be published, and they're both in consensus that the Lewin Current is likely to weaken by about 15 to 20% over the coming decades. It, of course, will still have that annual variability of being stronger and weaker around different, response to different climate drivers. But we're really talking about that longer term projection of how this current is likely to shift in the future. So those two plots that I've got is just really the projection out to 2016, and that red line you can see the transport within that current is a bit lower compared to the 1990s. So typically a weaker Lewin current has been kind of associated with cooler temperatures off our west coast. But in the future, we're going to see a little bit of a mismatch where, because of that background warming, we're going to experience warmer sea surface temperatures even when the Lewin current is weaker and further off shelf waters. Okay, so now we'll just get into some of the key climate variables that are associated with, the ocean and the marine environment. And the first one I'll touch on is sea level. So the Australia map down at the bottom. So this is just a summary of the change in sea level around Australia over the last kind of 30 years. I think it's 93 to 2023. And the arrows on the maps just pointing to areas where the rate of change of sea level is slightly higher than the rest of our coastline. So you can see that the southeast corner and the northwest shelf region is where we're seeing a higher rate of sea level rise compared to kind of that southwest corner of WA. And so there's pretty high confidence around the further sea level rise looking into the next 20 to 30 year climate projection timeline, and we're likely to see another potentially another 25 centimetre increase in sea level globally and also around Australia. The plots at the top is just to draw your attention to some of the sea level gauge data. So this is the observed data that we have, and I've just picked Hillary's, Fremantle and Esperance to kind of show you what the observed trend that we have seen that's been measured by these sea level gauges around these locations. And this is data that you can easily access through the Bureau's website and keep a track of it depending on which location you have. When it comes to sea level, we're starting to see some publicly available sea level model outputs that some organisations are putting out there. So this is one from an organisation called Climate Central, and this is a web-based portal you can go into, and they've put up around Australia some of their projections for sea level, and this is around 1.5 and a 2-degree warming. So just out of interest, I've just kind of zoomed in on Albany. So this is the Albany Harbour, and all those red shaded areas you can see is that coastal regions that's likely to be below the tide line under a 2-degree global warming. So another example here is the Broome region. So this is all the way at top. There's Broome, and you can see all those shaded areas that are likely to be below that tide line. And it looks like almost this peninsula is going to be kind of cut off from the mainland under that future 2-degree warming scenario. So that's just some examples of some information out there that you can access. The next one is ocean acidification, which is probably a key one when it comes to our crustacean and mollusk species. So ocean acidification is essentially just a chemical reaction between atmospheric CO2 and seawater, and the byproducts of that reaction in terms of carbonic acid and carbonate ions, which is what's absorbed by a lot of coral reefs and organisms that require that for their calcification process. So as the concentration of CO2 in the atmosphere increases, essentially that's going to lead to more production of that acid in the water. So that is changing the chemistry of the water, of the seawater, and less available carbonate ions for that calcification process to take place. So essentially, there's quite a lot of variability in that ocean acidification process globally, and the map here just kind of captures the latest information we have and the observed change in acidification around the Australian coastline, and a lot of that data you can see is sitting further offshore and does not really cover that nearshore area where it's all white. So essentially what we're seeing is there's lower rate of ocean acidification of our northwest shelf and northern Australian waters compared to the southwest waters of WA. And there's some kind of numbers there to kind of gauge that. Typically, the pH is sitting around between 8 to 8.2 around WA, and the projection in terms of what we can expect. One projection is, it's going to get down to anywhere from, below 8. So we're getting into that high 7.2 in the next 20 to 30 year timeline. But there's kind of differences in confidence around that projection, but is that it is we are going to see greater acidification happen off our coastline. The next key one is essentially it's salinity, but salinity can be influenced by a number of factors. And I guess there is some projection of what salinity or surface salinity is going to be, like much further of that nearshore area. And a lot of that salinity is also influenced by a number of factors, including what ocean currents are in play. And so there's not real information around that, the future projections for that open ocean sea surface salinity. But much more closer in that nearshore area, and particularly around our estuarine habitats, salinity, as we all know, is very much influenced by things like evaporation rates, rainfall, and heavy rainfall events and flooding. And also the Lewin current and then the seasonal strength of that Lewin current, particularly those estuaries on the southwest coast that have that sandbar barriers as well. So the trend for rainfall, I'm just going to break that down for the southwest region. It's just that winter rainfall pattern.
Yeah, that's the thing.
the southwest region is been drying for the last few decades, particularly since the 1970s, and you can see that the projection is that drying trend is likely to increase in the coming decades. So these maps here just kind of show the average. You can see all those shades of orange just relates to that declining trend in rainfall. Opposite to that is for northern Australia and northern WA, the rainfall around wet season has been increasing in the last couple of decades, and the projection is that that rainfall increasing trend is likely to continue. Particularly, we're talking about that wet season from October to April, and that's also to some extent influenced by that monsoonal activity and the timing and the onset of the monsoon that hits the Northern Australian. This map off to the right here kind of signifies those inland riverine stream flows, and you can clearly see here that all those orange triangles signify where that streamline has been quite low and showing a decreasing trend, whereas those two right up north is showing a significant increase. So that's the dual difference in trends between the north and the south. And this obviously has a lot of implications for our freshwater aquaculture systems. So then we get to sea surface temperature, which is probably a very key one. And in the nearshore area, a lot of that the sea surface temperature information, sea surface data kind of also relates to that subsurface water body as well, because it's just so shallow. The map here, again, it summarizes the trend to date, and this is showing that ocean temperatures around Australia has been increasing as it has been increasing globally. WA obviously sits in the Indian Ocean basin, which is one of the fastest warming basins globally. And those orange areas to the southeast and on the northwest shelf, that's where the rate of increase in sea surface temperature is higher than the rest of the coastline. And that's very much true for when we drill down to, like, when we look at a much more spatial scales, we can see that the rate of increase in sea surface temperature, say for the northwest shelf, is higher than areas like the south coast. And that trend is also increasing under a warming climate. And so on this map, I have put some of that projection information, which is provided from different sources using different modeling frameworks. They're all pretty much in consensus around this information because it's probably one of the most well-studied climate variable. So we're likely to see, in the next 30 years, a further increase by 1 to 1.2 degrees in sea surface temperatures across the north and the northwest. The west coast and the Gascoyne coast, where there's a little bit more variability, and that's because we've got that influence of the lower current. And then we come down to the south coast, that variability kind of drops away, and we're seeing about 0.8 to 1 degree further increase in sea surface temperatures along the south coast. The bar plot here is essentially extracting those sea surface temperature data for our state waters across WA, and all I've done is just to kind of show the mean annual temperatures from 1982 onwards, and in that orange bars just kind of indicating that decadal averages. So what's the average for the 80s, the 90s, and the 2000s, and then we see a step up in that increase in average temperatures across the 2010s. And then lastly, these are the the 2020s. 2024 was the warmest ocean year we've had across WA, and that just kind of reflects how warm 2024 has been globally. So with the warming climate, we are going to see more extreme events, and one of the key ones that we can do a lot of communications around and has big implications for our wild fisheries as well as aquaculture is marine heat wave events. And so without going into too much detail here, these plots here is just a bioregional breakdown of the number of marine heat wave days annually that these regions have experienced. And for across from the north, especially on the south coast, you can see that increasing trend in the number of marine heat wave days. And also, we're also starting to see higher category marine heat wave events emerge. And that was definitely the case last year. So accompanying, I've just kind of visually kind of presented some of the big marine heat wave events, the big one being the 2011 event that had the huge impact on the West Coast, and in the Gascoyne, it was predominantly Shark Bay. We've also had a big marine heat wave event in 2016 across Northern Australia, which impacted that Kimberley and Pilbara region. And then last year was probably the most prolonged and severe marine heat wave event to hit the Northwest Shelf. And you can see this is what it looked like from December to January at its peak, and then the marine heat wave moved down the coastline, and we saw above heat wave conditions last up until about July last year. The projections for marine heat wave days under a warming climate, again, there's pretty high confidence around this, and essentially you know, by 2050, 2060, we can expect around about more than 200 days to up to, you know, 350 days of the year being under a marine heat wave condition. So usually a marine heat wave, the technical definition is water temperatures are above that 10th percentile, and that projection itself is quite alarming, and will drive a lot of kind of adaptations for the species in those different regions, and also the impacts on the habitat as well. So in response to that future projection and also the number of events that we've recently had, DPIRD has recently been working on a marine heat wave response plan. So this plan really kind of outlines how we are monitoring, detecting and responding to these events as it applies to the wild capture fisheries and aquaculture sectors within our state waters. And this is just an example showing that timeline projection of the heat wave event that we had last year. And these are some of the information that's captured in the plan that I kind of just listed in there. I'm not going to go into too much detail of the plan for now. I know we're running out of time. For just lastly, just touching on tropical cyclone activity, because that's another extreme event that will impact northern WA. So essentially, some of the takeaway key messages in terms of projection of tropical cyclones is that we are likely to see a decrease in the frequency of systems that develop off WA and across Australia, but the proportion of those systems that do develop is likely to be of the severe category, so category 3, 4 or 5. And there's high confidence around this, that projection information. There's less confidence around whether these systems are likely to travel further south because of the warming climate, and also the timing, whether we're going to have a longer tropical cyclone season under a warmer climate. So I might just stop there just because I know we're wary of time, and yeah, take questions now or wait till the end.
I think in the interest of keeping time,
Yeah.
we'll move straight over to Hannah and Greta. But thank you so much, Arani. And for questions immediately for Arani, please pop them in the chat so you don't forget them. And we will be able to come back for a more rounded Q&A after the next presentation. So I'll hand over to you, Greta and Hannah. Thank you.
Great, thank you. Thanks for that, Arani, and thanks for inviting us to come along and talk about the risk assessment report. We'll be pretty quick and pretty brief because the report will be available online now, and we're very happy to answer any other questions after the presentation as well. So as mentioned at the start, my name's Greta Petzel and this is Hannah Fogarty, and we've recently completed that risk assessment for aquaculture with lots of help and input from operators and researchers through.
Yep, so today, just a quick overview of today's presentation. We'll be going through some climate information, so talking about industry needs, climate projections, and the different ways climate can intersect with the environment and aquaculture operations. We'll talk about how to prepare using risk assessments to explore where businesses might be vulnerable, where to access information, where to ask climate questions you need answered. And we'll look at what to consider when exploring the risks identified in the assessment. So talking about timelines, areas of businesses, unanticipated changes and risks, and adaptation actions.
And I think it's a really important topic. So I'm really grateful that Justin and Rachel have organised this. As you might have seen this information before, this is the most critical risks or barriers to future successes for WA aquaculture from the survey that Aqua and Haberlin put out in June. And you can see that the number one most common response there around what that big issue was for future success is environmental change. And obviously that's not the only issue, but it is a really major one, and can also exacerbate some of those other risks and concerns as well. So, you know, 46% of you said that you'd already observed some impacts of climate change or environmental change on your operations. And the top three things there were things like the drying climate, so drier, hotter summers, drier winters, lack of rain, obviously linked to that drying climate as well, and higher water temperatures. So all of the types of things that Arani just mentioned.
Yep. So in trying to make this sort of more interactive, if you scan the QR code here, we'd love to hear your thoughts and be able to share with everyone what your climate concerns are for WA aquaculture. So we'll stop here for a minute and just see what your answers are that pop up on the screen.
We probably should have forewarned you to get your phones out and scan that in and let us know what your concerns are. So this can be just a couple of words. So it could be, you know, you're concerned about temperature, or you might be concerned about an actual process. Yep, ability to adapt. That's obviously, and that's dependent on so many factors that we won't be able to get into today. So, you know, your own personal resources, the leadership in your industry or your sector. Access to fresh water, obviously a very major issue. Species health, I think disease will be a major concern. I mean, I know that's already a big issue for many sectors, but I think that might increase. HABs, obviously, riffing off the South Australian experience there. There's some few more people are typing. Immune response, interesting, yeah. Extreme weather events. Yeah, so extreme weather events can impact the species, or it might impact your infrastructure or safety for people working in your operation. Storm impacts. Yep, leadership at all levels will be required for the best responses that we can have. So I guess aquaculture's lucky in that you've got Justin and Aqua really leading the way around Australia for understanding impacts of climate change on aquaculture. So I think that's a good sign, but obviously state and federal support would be good there as well. Excellent. So look, that's really interesting to see all those results coming through, and we'll make sure that those are made available so that you can see what everybody else in your industry is worried about as well. All right, so we heard from Arani about how temperatures are changing, and it isn't just in WA. Ocean records are being broken everywhere for temperature. So as Arani mentioned, 2024 was the warmest that the ocean's ever been. This graph here just sort of puts that into a global context. So each one of those lines is an annual or is an average across the whole or most of the whole ocean from sort of accepting the poles at each ends. You can see the yellow line there is 2024, the red line's 2025, and they're sitting way above the averages, those solid or those broken black lines there. And that's a trend that we're expecting very definitely to continue. And over half the world's oceans experienced a marine heat wave in 2024, and we're probably a similar percentage of the ocean now. And that obviously has many, many impacts for our species around the diseases and the toxin risks, changes in size, productivity, almost every sort of aspect of life history.
So this image, if you viewed the FRDC climate briefing the other day, you would have seen this image there as well. This is observed impacts from marine heat waves from the summer of 2024 to 25. So we can see that WA observed a large marine heat wave last summer, particularly in the northern regions off Pilbara, Broome, further north, which saw fish kills and coral bleaching events. And there were some out of range species sightings that occurred in the southwest. Other impacts of the marine heat waves around the country last summer included reduced fish kills off off Northern Territory, coral bleaching off Queensland, fish kills in New South Wales, jellyfish and algal blooms off Tasmania, and an absence of penguin colonies. And of course, there was the large algal blooms in South Australia.
Yeah, so lots of impacts all around the country. Now, Arani's already talked about sea level rise, so we might skip over this one, except we've got an example from a recent paper about, exploring how aquaculture industries are vulnerable to sea level rise.
Yeah, so this one was recently published in Queensland. It's projected sea level rise scenario for the RCP 8.5, which is the extreme climate scenario, and it projects 0.8 metres of sea level rise to Queensland's coast by the year 2100. So by comparison, Fremantle has a projection of 0.6 metres of sea level rise by 2090 under the same scenario. So the study found that in Queensland, over 1/3 of the currently producing aquaculture sites are at risk, and 1/4 of development areas may be unsuitable for aquaculture due to their high exposure to inundation. They also found that 98% of prawn sites and 50% of the production are expected to be impacted. So this sounds scary, but it's important that we make these vulnerability assessments to be able to inform future planning, as informed adaptation measures will help to minimise losses and create more resilient aquaculture operations.
Yeah, so we just thought that was a good example about how much more detailed analyses around a particular climate driver or, a particular sector might be useful down the track. I've just got this graph here around CO2 emissions. They're going in the wrong direction. So this isn't a problem that's going to go away. We've had, a 60% increase in emissions since 1990. And even in 2024, emissions are still rising, by around 1% a year. So they are tailoring off a little bit now, but this will continue for the foreseeable future. So the kind of risk assessment process that was commissioned by Aqua, I think, is a really great place to start. So in terms of a risk assessment, you can either spend a whole lot of money on one particular species or one particular production system and then end up with, you know, quite a detailed study that's got lower uncertainty. Or you can, and this is where, you know, we would often recommend industry start off, you can look at a whole range of species doing a qualitative sort of scoping type assessment, which is what we did with the aquaculture industry here. So we looked at a large number of species and did a relative assessment to look at what some of the potential impacts might be. So this is what we did for WA, looked at a whole range of species and a whole range of different production systems. So the risk assessment report we did was really a screening level risk assessment. So it's really about risk identification, trying to identify what all of those risks might be or what the key risks might be. And we developed the approach in collaboration with other aquaculture researchers and with other industry people. And then the results were verified or ground truthed, I suppose you'd say, through collaboration with different operators, some of which are probably online here. And it's now been published online. We're not going to go into the detail of the assessment, but very briefly, we literally looked at as many different parts of that entire aquaculture production system as we could and looked at all the different components and the potential risk points. So we looked at the hatchery nursery phase, we looked at the grow out phase, we looked at some overarching risks, so things like diseases and pests and infrastructure exposure to extreme events. And we also looked at that harvest, market and transport part of the process as well. So not going into the detail, it's all available in the report online, but just to show you that we tried to pull apart that whole production system and look at where and how climate change interacts with every one of these components.
And so we did want to show you just this one here. This table isn't actually in the report, so I did this for today. Just want to show you a ranking of the 15 species attributes that we assessed to highlight which attributes were most frequently rated the highest risk among the assessed species. So the sensitivity scores, impact scores and risk scores for each assessed species were summed together and then ranked 1 to 15. Then these three ranked scores were then summed together and then the totals were then again ranked 1 to 15 to get an overall risk ranking of each species attribute. So the top three most at-risk attributes came out as, across all species, came out as connectivity to the natural environment, farming operations exposure to extremes, and infrastructure exposure to extreme events.
Yeah, so they're just the aspects of aquaculture systems overall that look like they might be more vulnerable to climate change.
So why is connectivity to the environment and exposure to environmental extremes so important to consider? So not only do we need to consider the gradual increases in water temperature, ocean acidification, those sorts of things, but the extreme events that occur due to anthropogenic climate change are increasing in intensity and frequency and can have fast and devastating impacts. So therefore, we need to consider and adapt for the risks of both exposure to the environment and exposure to environmental extremes. So we've got some examples here of how climate drivers could impact different areas or attributes related to aquaculture operations. So some physical impacts might be water temperature increases driven by heat waves, salinity changes driven by extreme rainfall events. Moving on to the biological impacts, there's some spatial redistribution of prey species might be driven by increased water temperatures, accumulation of pathogens from warmer waters, and operational impacts may have personnel safety driven by heat waves, bushfires, storm events, power outages and infrastructure damage from increased storm events, storm frequency and intensity. And it's important to note that this is not an exhaustive list either. There will be various other impacts, some negative, and also there will be some positive impacts as well.
and probably a few surprises that we've not thought of. But as you can see, it's a pretty, even though it's not an exhaustive list, it's a long list of many different ways that climate can intersect with aquaculture. Now, with the kind of assessment that we've done, there are some limitations. So in some cases, we might not have had the data to really consider how those attributes of the aquaculture process might be impacted by climate change. We weighted all of those attributes equally for each different sort of species or production system, when in reality there might be one particular aspect of production that would be an absolute deal breaker if there's a particular impact to climate change. So that's something just to keep in mind while we're looking at the results and looking through the report. Yeah, but so really this is really about trying to provide some high-level guidance on where climate change might impact different aspects of the physiology, the life cycle, or the farming process. And it's important to remember that climate change will absolutely impact every species and every production system. And it's those that assess the risk and really try and start thinking about adaptation that will really be able to cope much better.
So when exploring the risks and impacts of climate, something to consider is how climate may impact different areas of your business. So, for example, you might consider the level of connectivity to the environment and environmental extremes when selecting sites. Consider the level of resilience for farm species to temperature and salinity changes, and implement selective breeding practices where possible or needed to improve species resilience, and also consider diversifying stock species. Consider the biosecurity of your operations, as warmer waters may increase the frequency, speed and extent of disease outbreaks. Consider how extreme weather may cause disruptions to your supply chain or affect harvest yields, such as from heat waves, storm damage, power interruptions. You may consider how increased climate impacts and risk may impact insurance premiums and investment attractiveness, and new environmental standards and reporting requirements may be introduced, which might affect your operations.
Yeah, and I noticed that one of the Slido comments earlier was about challenges around investments and how climate change might affect that sort of financial side of things, which I think is a really important consideration.
So you may need to consider how different timelines or timescales will affect the frequency or intensity of climate impacts on aquaculture operations or infrastructure. So, for example, short-term impacts may look like increased frequency in storm weather events, some infrastructure vulnerabilities from flooding, bushfires, heat waves, ocean soil, for example, or regulatory or insurance changes as extreme weather events become more frequent. Medium-term impacts may look like greater shifts in species distributions and productivity, a need for adaptive infrastructure, so maybe using integrated multi-trophic aquaculture systems or diversifying farm species. And market and supply chain disruptions due to extreme weather events may become more frequent. And then long-term impacts, so up to the year 2100, may see permanent loss of low-lying aquaculture zones, major shifts in viable farming regions, and inability to farm certain heat-intolerant species in the natural environment. So we need to expect the unexpected and put plans in place to be able to quickly react to unexpected changes or risks. So, for example, simultaneous events could have cascading effects on operations and infrastructure, such as if a heat wave or flood co-occur. Weather patterns will become more unpredictable due to the impacts or changes of complex systems like El Nino or the Indian Ocean Dipole. Loss of employment or in regional communities or food security concerns may create social and economic shocks. Consumer preferences may shift. So, for example, there may be a high demand for carbon resilient or low carbon seafood, and unexpected changes may result in technological gaps, such as technology becoming unsuitable or inaccurate early warning systems.
Yeah, and things like those shifting consumer preferences, they may actually be positive. So even for many aquaculture systems, seafood is often a lower carbon protein source, so it can be sort of part of a low carbon future, and that might be something that becomes much more appealing and a point of marketing that can really sort of help in some cases.
So designing an adaptation plan. So I'd encourage you to read the FAO Adapt report that was recently released. It outlines a 6-step process for assessing risks, planning, implementing and monitoring adaptation strategies. So they write that the selection of adaptation actions should first involve the reduction of risks through reducing exposure, so maybe through spatial planning to avoid locating farms in high risk areas, reducing risk through reducing sensitivity or vulnerability, so improving biosecurity or lowering stocking densities to reduce stress or health issues on stock, and reduction of risk through increasing adaptive capacity. So this might look like implementing monitoring or early warning systems, using more resilient genetic strains through selective breeding, or using oxygenation systems such as microbubbling. And the selection of adaptation actions should also involve the use of new opportunities created by climate change. So for example, increased temperatures could enhance the growth of some species and expand farming ranges, or new species may be able to be farmed that were previously unsuccessful. So what to include in an adaptation plan? A timeline that is clear and realistic, defined roles and responsibilities for all involved, and an analysis of the cost effectiveness of each adaptation measure.
And I guess one thing to remember is that when we're talking about adaptation options, you're obviously after trying to identify things that are rational, that are appealing, and that are efficient. But as climate change kicks in and the changes get larger and larger and larger, what is rational, efficient and appealing will actually shift in time. So just highlighting that to show that, you know, adaptation options that just seem like they might not have the right cost benefit outcomes, or might not really be feasible or appealing now, in 5 or 10 years, then they might certainly become more appealing as that sort of climate landscape shifts and changes. So we've just got another Slido poll here. We'd be really curious to try and understand what uncertainties do you have or around climate change and adaptation.
And this should be the same QR code as the last one. So it should just on your phone just pop up with the new question now.
Have we got one more up?
We've got one more
Yeah.
one, yeah.
Yeah. So we can see some of you typing. Yeah, where to start, and I guess I think that's why it was so good that Aqua did this scoping assessment, because for the species that were involved in this report, you'll be able to go through and see what are those biggest risk areas for different parts of the production system. Yeah. Yeah. What does it mean at the local level for my farm? Then that is really tricky, because it can be quite costly to do the analyses at such a small fine scale. Doesn't mean that it's impossible, but that's obviously an option for perhaps larger businesses, and might be something that's more or might be a bit prohibitive for smaller operators. See the timelines there, when it will affect particular businesses, and that will be very regionally variable depending upon species as well. Environmental tolerances of species, hopefully for most of your species there's at least some basic information available around environmental tolerances. So yeah, depending on what species that was, if you send us an email, we can try and find what information there is available. Or actually, that's a great question for the Sea Change Australia program, which I'll introduce in a minute. So if you'd like to know what information is available around the environmental tolerances for a particular species, log that as a question on Sea Change, and we can get that answered for you. And then comments there about state government policy not evolving fast enough. I would agree there, and I think that unfortunately is the case for most of the states around Australia. But yeah, interesting to see what concerns you have there. And the comment there, climate change is all about uncertainties. That's absolutely correct, unfortunately. So how to prepare? So risk assessments are a good start, like the scoping assessment we've got here. And just to really try and pull apart those different phases of the production system and see where those sort of high vulnerability points might be. Accessing information is obviously a great start. We've already mentioned the FRDC climate briefings, or maybe that was in a previous talk.
Yeah,
It was in this in this webinar. We've got the link up there for you as well. They're being hosted fairly regularly. Anybody can tune in and listen to those. There may also be state-based briefings for different places, and we'll have all of these mentioned on the Sea Change Australia website. So we're developing a calendar at the moment that should have any sort of webinars or climate briefings that'll be available around the country. And yeah, ask any questions to Sea Change, which I'll introduce just after this next Slido. So this is a question really about how confident are you at the moment around your sector or your business's ability to adapt to climate change. And obviously there might be a range of different perceptions there, and it really is quite complicated because I think it does depend on your own industry's resources, the support you can get from state and federal levels, and a whole lot of different reasons. So we've got some confident people there. That's always good to see. And we've got some other people typing. Yeah, I'd expect this to come out with a range of responses. So we might move on there, but please keep responding to that, because I think this will get disseminated afterwards, and it'll be really good to understand where everybody's at with that. So super quick introduction to a national project called Sea Change Australia, and we're very grateful to have Arani as part of this project. Rachel works on it as well. So Sea Change Australia is all about trying to co-develop options to adapt to a changing climate for fisheries and for aquaculture. And it's really about trying to bring seafood producers, researchers, and managers all together to engage in lots of two-way conversations and discussions around climate change, because all of those groups need to adapt. It's not a case of industry needs to adapt. We need to adapt how we're delivering information and how we're interacting and assisting industries, and managers obviously need to adapt what they're doing as well. There's different parts to the Sea Change project. I won't go into them, but one of them is answering, so if you can submit questions you've got on climate change, we pair your question up with an expert in that area and they'll answer that for you, and then we pop that up on the website for everybody to go and have a look at. So you can go to the Sea Change Australia website and see questions that other industry people have asked and some answers to those. You can submit your question. And we're also interested in any stories of adaptation. So if you've already made changes, it's wonderful to let us know so that we can start collating those and sharing those with other operators, because the more that people collaborate and help each other, the better we'll all be with climate change. So we've got a QR code there for Sea Change Australia. So that's to join our mailing list. Would love you to log on to the website and have a look. So we'll finish there, and yeah, we'll love to hear any questions that you've got. We haven't been checking the chat, so I'm not sure if there's any questions in the chat there. There's a QR code there as well to the risk assessment report. Thank you.
Thank you, Greta and Hannah. And just quickly to flag that the Sea Change programme is a national programme focused obviously on the seafood sector, but discussions with Hannah and Greta are that they are happy to also receive freshwater questions that are relevant to aquaculture in WA, which is a bit different from in other states as well.
Yeah, WA is special.
Yeah. Thanks, folks. I don't know if you want to chime in. Feel free to put your hand up or talk or drop a question into the chat. But I might just read just a reflection from Justin in the chat around environmental tolerances. And he said, it's not just about taking the extremes at which species survive into account, because many do not reflect the realities in the environment, but also looking at using tolerances that are considered with reproduction as it's a more limiting factor.
Yeah, and these things always interact. So often it's not just temperature on its own. It might be temperature and oxygen, or temperature and oxygen and salinity, or food availability. Often there's a very strong difference between the temperatures that a species is quite happy at, depending on food availability, for example, or what sort of energy stores and reserves that they might have, or previous stress, things like that. So it's never straightforward. I've had quite a few PhD students doing environmental tolerance work here with squid and rock lobster and fish species, and it's always a bit of a nightmare to try and unravel. But obviously, it's it can be a reasonable indication of how the survival of your species might go under particular temperature regimes.
Greta, I had a question that came to mind as you were talking about, and Arani was talking about water acidification, and it was related actually to Justin's enterprise in the Abrolhos, and that was whether proximity to coral reefs or limestone islands had any greater buffering capacity for calcium carbonate concentration in the water, and whether that offered any sort of insurance against acidification. Have you seen anything of that nature?
I would probably have to go and consult an acidification expert to answer that accurately, but I do know that local habitat species do have a buffering effect. I just don't know the magnitude of that. So it's exactly right. It's a good thing to be looking at and considering, but I'm not sure the magnitude of that kind of effect. But acidification, I think, is going to be a really big issue. There was a report that came out a couple of months ago showing that for many ocean regions, and I think it might have been 27 or 30% of the ocean, that has already passed what they're referring to as a tipping point for acidification. So past a critical point for many species, and it's something that a lot of us have ignored. Myself, not ignored, that's probably the wrong way to phrase it, but we've all been much more focused on temperature. Temperature's been an easier thing to measure and to work with, and something that's been changing fairly fast, leading to obvious impacts. But acidification is absolutely something that we really should be taking very seriously. Any other questions or any comments that people want to make about their own operations? Or so Larissa's got a question there saying, is it possible to have temperature controlled indoor aquaculture prospects? It absolutely is. That's something that Justin might have more information on. But obviously, and then that's exactly what the risk assessment process demonstrated, was the more exposed to the external environment that species or production systems are, then the higher the risks. And that's a pretty sort of basic finding to arrive at, is a very logical assumption. But there are certainly ways that that exposure to extreme events or to temperature can be addressed in some cases for many systems.
I have a hand up from Mary. You're on mute, but let's see if we can.
All right, Mary, someone's got to do it in every webinar.
Sorry, I joined late, but we're yabby producers in Western Australia, and our industry has been devastated through aerial spraying of pesticides across our across all the regions. So we're just battling to stay alive. But I just wish somebody would get out there and talk about the effect of pesticides on our climate and the destruction to our environment.
Yeah, Yeah, that is a massive issue, and I do know a very good researcher in New South Wales that's looking at that. She's looking in particular at the runoff from agriculture and how that's affecting aquaculture systems and fisheries and waterways in New South Wales. I could ask her if she has any sort of information on researchers in WA that are doing similar things. But yeah, that is a really massive issue. And obviously, as land production systems get under more and more stress, so agriculture gets under more and more stress, then all of the use of all of those things, unfortunately, often increases as well. So that's something that I think is very important.
What we're experiencing is aerial spraying, which of course has an inversion of up to 2 kilometres. And of course, we've bought from hundreds of farmers over the years, up to 1,200 actually. And when they ring me up and they say they've got no yabbies, I'll ask if they've used pesticides. But what my concern is that nobody's looking at the viability of these pesticides into the future, because they're not just killing our aquaculture, they're killing the environment and they're killing the insects and the biology in the soil.
Yeah. Yeah, no, I agree. I don't really have an answer or a solution, but that is a really important issue, definitely.
I just want you to all get involved and somebody to actually do some active research and talk to governments about what is being allowed to happen, because it is devastating.
Yeah.
I mean, it's destroyed our business. Our biggest week was 4.1 tonne of yabbies, and we can't even get 100 kilos at the moment.
Yeah. Mary, if you send me an email, I'll put you in contact with the researcher in New South Wales. She's been on a pretty heavy campaign around similar sorts of issues there. She might have some suggestions for how you could go about it in WA, if that's of interest.
Absolutely.
Thanks, Greta and Mary. And just flagging that Larissa popped a link in the chat for you, Mary, so don't miss that either. Folks, it would be great to stay on all afternoon, and I'm really impressed that everyone has stayed on till the end and beyond. But given that we're 7 minutes over time, we will end it for now. You can follow a link to the risk report there, and there's details for Greta and Hannah. And please just get in contact with us at Aqua if you want to connect with Arani or anyone else who's also definitely available online.
And
so
can I say one more thing, Rachel?
Of course, yes.
I forgot to mention that the risk assessment process that we worked through for those 15 different species and production systems, Hannah's converted that into an Excel spreadsheet with drop-down sort of selections where you can answer the different questions. So we've sort of tried to adapt that into a tool that people can download and use on their own to try and identify the risks for their particular operation. So we'll make sure that is sent around when that's available and online as well. And we're happy to answer any questions that people might have if you do have a go at that yourself.
Yeah, amazing. Thank you, Greta. I think that will be a really useful resource for individual businesses. Arani, any last words, given that we've had lots?
No, I guess if just a quick outlook for the summer ahead. So we're definitely warming up. Waters around Australia is warming up, but it looks like probably at the moment the outlook is that the East Coast is going to maybe potentially experience more marine heat wave like conditions than the West Coast at the moment. Just that's what's at play at the moment. So hopefully not going to be such a severe summer like we had over 24-25, so which is good news, but the climate always throws curveballs at us, so keep an eye out for a lot of those briefings coming out from FIDC, the Bureau and CSIRO, and I can put up a link to when I think we're going to have probably another 4 briefings over the coming summer as it progresses.
Yeah, and the climate briefings that we were discussing will be linked on the Aqua newsletter, so you'll be able to access that information through us as well. Okay, thanks again so much, folks, for joining us. Thank you, Arani, Greta, and Hannah. It was great to have you. And any questions on the report, please get in touch. Have a great afternoon. Bye, folks.
Bye.